Selective laser melting, or SLM, is an advanced metal additive manufacturing process that creates fully dense metal parts directly from a digital design. The process begins with the design of the part in CAD software. At this stage, the geometry is created, reviewed, and optimized for additive manufacturing, taking into account functional requirements, complexity, and printability. Once the design is finalized, the model is prepared for production. The part is oriented within the build space, support structures are added where needed, and the geometry is sliced into thin cross-sectional layers that will guide the printing process. Before printing begins, the metal powder must be carefully prepared. Because powder quality is critical to the final result, it is handled under controlled conditions to preserve consistency and performance. A dehydration step is carried out first. This helps remove moisture from the powder and reduces the risk of contamination, ensuring better process stability during printing. The powder is then sieved. Sieving helps maintain the required particle quality and removes agglomerates or irregular material that could affect layer deposition and final part quality. After preparation, the powder is ready to be loaded into the machine. At the same time, the SLM system is prepared for the build, including the installation of the build plate and the setup of the powder handling area. The specially integrated gloves installed on the printer allow the user to access the interior of the machine without being exposed to the metal powder and without disturbing the inert gas atmosphere maintained inside the system before and during the printing process. Inside the machine, the printing process takes place layer by layer. A thin layer of metal powder is spread evenly across the build platform using the recoating system. A high-powered laser then selectively melts the areas defined by the digital file. As the laser scans the surface, the powder fuses into solid metal, forming the first cross-section of the part. Once one layer is complete, the build platform moves downward by a very small distance. A new powder layer is spread, and the laser melts the next section of the geometry. This sequence is repeated over and over again. Layer after layer, the part gradually takes shape inside the powder bed, allowing the production of highly complex geometries that would be difficult or impossible to manufacture with conventional methods. After the printing process is completed, the excess powder is collected through dedicated filters located at the rear of the machine, allowing it to be recovered and reused. Before reuse, the recovered powder must undergo an additional sieving process to ensure safe and consistent operation. This step removes oversized particles and other contaminants generated during printing, which may otherwise affect powder flowability and layer deposition. By improving powder quality, sieving supports process stability, reduces the risk of defects, and helps ensure that the material can be safely reused in future printing cycles. The printed component is then separated from the build plate. This marks the transition from the printing stage to the post-processing stage, where the part can undergo additional finishing operations depending on the final application requirements. After post-processing is completed, the part is ready for use. At this stage, the component has reached its final form and can be prepared for its intended industrial application. If you found this video useful, hit the like button and subscribe to the channel for more content on additive manufacturing.